Histograms and box plots. So like line plots and stem and leaf plots, histograms and box plots are also best suited for numerical univariate data. So it says fill out the frequency tables and create histograms for the following data. Okay. So before we can kind of determine what these data displays are best for, it makes more sense to make sure we know how to make them so that we just kind of understand how they're built before we can do any sort of interpreting. So it says fill out the following frequency tables, create histogram. Okay, so the way I like to do this, I like to just go one at a time and make tallies. So a 50 would go in this interval. I'm going to do tally marks. A 42 is also in this one. A 119 is here. 45 is here. I'm going to go kind of fast. 68 is here. 32 here. 67 here. 111. 61. 31, 75, 39, so there, 62, 64, 49, 55, 51, 33, 117, 96, 64, hope I didn't mess up, 82, okay, so my frequency, now I'm going to just kind of add them up. So from 0 to 20, there wasn't any. I'm going to put a 0 there. There's 4 here, 6, 7, 2, 3. Okay, so how many total do I have there? Being a little OCD here, I think there's 22. Let me make sure I have 22 data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 20. Okay, I think I did it right. Okay, now let's make the histogram. So from 0 to 20, there's nothing. 20 to 40 was 4. So I draw my histogram like this. 40 to 60, there was 6. Uh, 60 to 87. 80 to 100, just 2. And then 100 to 123. Okay, so that's how you make a histogram. Just find the frequencies and you put it in there. So what's good about histogram, it helps you see the shape of the data. So this data is pretty normal, I would say, maybe a little skewed to the right. I don't know, but for the most part, the data is pretty normal. As we got the, from 60 to 80, we see the most of the data value. So again, histograms are best for kind of showing us the shape of the data. It's really good to see the shape of the data. Most of the data is kind of clumped there in the middle. So that's what histograms are good for, showing the shape of the data. So I'll let you make a histogram on number 2. Now we're going to move on to box plots. And you might have heard it as box and whisker in previous grades, but we're just going to call it a box plot. So it says find the 5-number summary for the following data sets and create a box plot. So in order to create a box plot, you first need to put the values in order from least to greatest. So the smallest one here is 8, 14, I think, then 19, 21, 24, 26, 27, there's a 28, there's a 29, okay, a 32, and then a 43. Okay, so let's fill out some of the obvious. The minimum is obviously 8. The maximum is 43. The median is the middle number. So I'm just going to eyeball it. because I don't want to have to erase and stuff. So I think the median is 26. Yeah, there's 5 on each side of that. Okay, so the median's 26. That's in the middle. And you can like, you probably in the past have slash until you got to the middle. But I didn't want to do that because I have this pen tool that isn't that great and there's no back button or undo button. Okay, so then the lower quartile is the median of the lower half. So I don't use 26, okay? Keep that in mind. I don't use 26. That's my median. So now I'm just looking what I underlined in green. I'm going to try to find the median of the lower half. That would be 19. And then the upper quartile is the median of the upper half, which would be 29. So if I create this box plot, the box is from the lower quartile to the upper quartile. So 19 would be, or they might call this quartile 1. The median's at 26, just kind of estimating there, and the quartile 3, or the upper quartile, is at 29. So this is my box. And then my minimum's 8, so I don't know, over here. And then my maximum's 43, so maybe over here. And then I can connect there. So that's my box plot. It's like I guess you can call it box and whisker. It's a box plot. So what's great about box plots is it shows you particular things like the median. You can see the different quartiles. And remember, quartiles, it kind of means like 25% of the data, and you should have learned this in previous courses. You don't need to write this, but 25% of the data is here, 25% of the data is here, 25% of the data is here, and 25% of the data is here. So it splits it up nicely, kind of in fourths. And again, like I said before, it's really good for showing us like the median and some other features of the data. So that's what a box plot's good for. Let me make one more box plot for you. So I go 20. Is that the smallest one? Yeah. I see a 24, 29, 30, whoops, 32, 38. That's 40, 41, 45, 58, and 65. Okay. So minimum's obviously 20, maximum 65. The median, okay, so this is why I wanted to do this one for you, because the median is kind of two numbers. There's no number right in the middle. The median would actually be between 32 and 38, which, so you're going to have to, because the two middle numbers would be 32 and 38. There's not a singular middle number. So to get that median, you find whatever's in the middle of 32 and 38. Now, if your mind thinks of a number line like mine always does, I know it's 35. 35 is in the middle of 32 and 38. And if you didn't know that, you just find the average of the two numbers. Do 32 plus 38 and divide by 2, and you get 35. So that's how you can get a median. And keep this in mind, even when you're doing the quartiles, if there happens to be like 2 in the middle for the quartile, find the middle of the numbers. That's going to be your quartile. Just add them up, divide by 2 or something, or if you just want to think of it on a number line, that as well. So the median is 35. So I don't think we're going to have any issues with the quartiles then, because there's a clear lower quartile, 29, and a clear upper quartile, 45. So 20 minimum, maximum. I'll use the same color coordination here. 45 for the upper quartile, 35 for the median, and then 29 there. So the box is from the lower quartile to the upper quartile. And then the rest. So yeah, like I said, like the box plots are really best for like quickly identifying what the median is and the quartiles. So that's what's great about box plots. You can immediately look at it and say, okay, the median's 35. And on this one up here, you can look at it and say, oh, the median's 26. We got different quartiles. That's what's really good about box plots. If you look at like a histogram, like up here, I don't know what the median is by looking at the display, right? I don't know what numbers in the middle. It just kind of groups the data. It's probably between 60 and 80, but I don't know what number between 60 and 80. Like I don't know what the exact median is. Meanwhile, the box plot shows me the exact median. So I'll let you kind of answer number 3 and 4 based off of the kind of rambling that I went on in terms of what's best with each of these plots.